I hope by now you have a grasp of how to get the readings from a vernier caliper. But what makes perfect? Practice. Let's take an example of how to find the diameter through the vernier caliper. Consider the diagram on this side for our example. Let's find the diameter of the cylinder placed between the outer jaws of the vernier calipers as shown in the figure. We begin by closing the jaws of vernier calipers and taking the main scale reading. The main scale reading is 0.0 centimeter. Next, we have to determine the zero error to conduct zero correction. So, the number of divisions coinciding with the main scale are 7. We multiply that 7 with 0.01 centimeters, the least count of the vernier caliper, to determine the vernier scale reading, which is 7 multiplied by 0.01 centimeters, which is equal to 0.07 centimeters. So now we know that minus 0.07 centimeters is the zero correction of this vernier caliper. Moving on, we determine the diameter of the cylinder by noting the reading on the main scale, which reads 2.2 centimeters. We move on to the vernier scale reading. The number of divisions of the vernier scale coinciding with the main scale are 6. Repeating the same step we did before, we multiply the number of divisions with the least count, that is 6, multiplied by 0.01 centimeter, which is equal to 0.06 centimeter. Hence, the observed diameter of the cylinder is 2.2 centimeters plus 0.06 centimeters, which is equal to 2.26 centimeters. But you do know that the correct diameter of the cylinder is found by subtracting the zero error correction from the observed diameter of the cylinder, right? So, 2.26 centimeters minus 0.07 centimeters, which equals to 2.19 centimeters, is the correct diameter of the cylinder. Apart from the manual vernier caliper, a digital vernier caliper is also available. See, it is indeed very simple to use. The least count of the digital vernier caliper is 0.01 millimeter, which means it is more precise than a manual vernier caliper, and the readings are more accurate as the digital display is very sensitive to the movement of the vernier and main scale. So, I hope you understood this topic well. Stay tuned for more learning.